All right, so today we're going to be talking about balancing and translating word reactions. And in order to actually balance those reactions, we have to first translate them from words into chemical symbols. And then after that, you can balance. Some things to remember when translating word reactions into chemical equations is that the words mixed with indicate that you have two reactants added together. When you hear the words produce, is produced, or production, that's going to indicate the reaction arrow or the products of a chemical reaction. The term solution indicates an aqueous solution or AQ within the actual reaction. This indicates that you have an ionic compound dissolved in a solid. Dissolved in water. The word combusted indicates a reaction with oxygen. And the term Hänkelbrief is just kind of a goofy way to remember the diatomic elements. Each of these elements, when their name is written, for example, hydrogen, if you see hydrogen in a chemical reaction, the formula is going to be H2. All of these elements are written with a subscript of 2. That's how you know that they are diatomic. They cannot exist alone in nature. So other examples would be O2, N2, Cl2, Br2, I2, and F2. These are the diatomic elements. And this is something that often trips people up. And then the last thing to remember is not to forget to include states of matter. So let's go ahead and do an example. Number 1, a solution of chromium-3 nitrate is mixed with a solution of ammonium sulfide to produce solid chromium-3 sulfide and a solution of ammonium nitrate. So there's a lot of information here in this problem. So what we're going to start off by doing is just writing the formulas from the compound names because we know how to do that already. We know that chromium is Cr, and this 3 Roman numeral indicates the charge of chromium is a +3. Nitrate, NO3 minus, one of our polyatomic ions, has a charge of -1. So I know that for every -1 charge, I need, for every +3 charge, you need 3 -1 charges. So we're going to end up with CrNO3, 3. And we know it's a solution, so it's going to be aqueous. If it's mixed with something, we are going to add them together. A solution of ammonium, which again is another one of our polyatomic ions, NH4+. Sulfide is just a sulfur ion with that -2 charge. And I know I need 2 of the positive ones to balance out my -2. So I'm going to end up with NH4,2S. And again, it's a solution, so it will be aqueous. So from here, I know that these two things mixed together are going to produce something. So I'm going to include my reaction arrow here. Solid chromium-3 sulfide. Again, Cr+3 sulfide with a -2 charge. So in order to balance those out correctly, Cr2S3, and they told us it's a solid, so we're going to put a little S in parentheses after it. And always indicates a plus sign, a solution of ammonium nitrate. Ammonium, again, we know is NH4+, and nitrate, again, we know is NO3-. So I need one of each to make a balanced or a neutral chemical formula. So NH4NO3, and again, it's a solution, so we are going to write aqueous at the end. That is our written formula, and now we need to go ahead and balance the equation. So I know that I have 3 nitrates on this side and 1 nitrate on this side. So I'm going to put a 3 here to balance out the NO3s. Now I notice that I have 3 NH4s and 2 NH4s. So that's not going to work, but I'm going to set that aside for now. I also see that I have 2 chromiums on this side, so I'm going to go ahead and put a 2 here. But if you notice, that's going to change our NO3s to 6. So I'm going to erase this and I'm going to change it to a 6. So now that makes it a lot easier for me to get 6 NH4. So I'm going to put a 3 in front here, and everything is balanced. And that is our final answer for this reaction. Now you could always use your T-chart to balance the equation. I didn't, just for the sake of time. Let's take a look at another example. So in this example, they give us the name of the compound, but we don't necessarily know what that means. So they also give us the compound. So C2H6, that's an easy one. It's given to us. And it's combusted with oxygen gas. Now, combusted, we know, means that it's reacting with oxygen gas. And oxygen is one of the Hunkelbrief elements, so we know it has to be diatomic. And we're going to include G for gas. It's reacted together to produce, we know that means the reaction arrow, gaseous carbon dioxide. I know that means that I have a single carbon and 2 oxygen, and it's going to be a gas. And indicates the plus sign, steam, which is just gaseous water. So in this case, we've already written out our equation, and that was pretty quick. But the next thing that we're going to do is go ahead and balance it, and this is going to be kind of the harder part of this problem. So we know that we have reactants, we have products, C, H, and O. And what we're going to do is just take an inventory on each side. We've got 2 C's and 1 C, 6 H's, 2 H's, 2 O's, 3 O's. So I'm going to change color so it's really clear what I'm doing. But I'm just going to start with hydrogen, just for fun. Doesn't really matter which one you start with, carbon or hydrogen, as long as you don't start with oxygen. So let's get 6 on this side. So I'm going to put a 3 over here. Now we have 6 hydrogen, and we've also changed the number of oxygen we have from 3 to 5. So the next thing that we're going to work on is the carbon. So I've got 2 carbon over here, so I want 2 carbon over here. So we've got 2, and now we have 4 plus 3, that's 7 oxygen. So everything's balanced except the oxygen. And just to show you a slightly different way to balance these types of reactions, what you can do is actually just put in that you have 7 divided by 2, because we need to always use whole numbers in here, and we're going to solve that problem in a minute. But I know that if I have 7 divided by 2 times 2, that's going to give me 7 oxygen atoms. But we need to have whole number ratio. So we're going to just multiply everything by 2. So 2, this is going to give us just a plain old 7. We're going to get 4, and we're going to get 6. Let's check and make sure that everything's good. I'm going to use a different color this time. So now we've got 4 carbon, we have 12 hydrogen, and we have 14 oxygen. And on the other side, 4 carbon, 8 oxygen, plus 6 oxygen is 14. And 6 times 2 is 12. Everything is, in fact, balanced. So then let's quickly do the last one, and I'm going to let you balance that one on your own at the end. So solid vanadium metal. the chemical formula for vanadium metal is just going to be V, and it's a solid. Reacts with it indicates a plus sign. Solid cadmium phosphide. We have Cd, which always has a +2 charge, phosphorus, which has a -3 charge. So to balance those out, we're going to get Cd3P2, and we know it's a solid. They are going to produce, that's a reaction arrow, solid vanadium phosphide. That's V5, +5 charge because of our Roman numeral here, and P -3. So to correctly balance out those charges, we're going to have V3P5, which we just said was a solid, plus solid cadmium metal. So in this case, we're going to have Cd solid. And that's how you're going to write the chemical reaction. I'm going to let you practice the balancing of this problem on your own, and I will post the final answer key up a little bit later. Thanks for watching.